everyone, this is Sir Jason Alviar and welcome back to Mathusay Math 10 tutorial. In this episode, you will learn how to solve problems involving geometric series. Let's begin. In Lesson 14, Part 1, you have learned how to find the sum of the first n terms of geometric sequence using the formula S sub n equals the first term times the quantity of 1 minus r raised to n all over 1 minus r, provided your common ratio should be not equal to 1. Also, in Lesson 14, Part 3, you have learned how to find the sum of infinite geometric series using the formula S is equal to the first term all over 1 minus r, provided your common ratio is between -1 and +1. So in this lesson, we will use this to solve real-life problems. Let's start. Example number 1. Linda starts a chain letter and sends it to 3 friends. Each of the 3 friends sends the letter to 3 other friends. And the sequence is repeated. Assuming that no one breaks the chain, how many letters will have been sent from the first through the 6th mailings? So, we know that in the first time when Linda sent a chain letter, she sent it to 3 persons, right? So, now these 3 persons who receives this letter will send it to another 3 persons. So, on the second sending of mails, there should be 9 letters sent, right? So, that's why the common ratio is 3. Now, we want to know how many letters will be sent on the 6th term. So, our n is 6. So, we want to know the sum. Again, we want to know the sum of the mails sent from the first time Linda sent it and up to the 6th terms in the given sequence. So, we have S sub n equals a sub 1 times the quantity of 1 minus r raised to n all over 1 minus r. So, we know the first term, we know the common ratio, and the number of terms in the sequence. So, substituting these values, we have 3 times 1 minus 3 raised to 6 all over 1 minus 3. We know that 3 raised to 6 is 729. So we have 3 times 1 minus 729 in the numerator, and in the denominator, we have -2. So simplifying 1 minus 729, we have 3 times -728 all over -2. So since we can divide -728 by -2, we have 3 times 364. Now, 3 times 364, we know that that will be 1,092. So, it means to say that there will be 1,092 letters sent or mailed all in all. Let's take another example. Example number 2. Show that the repeating decimal, non-terminating decimal 0.27, 27, 27, 27, and so on is equal to 3 over 11. How do we show this? That 0.272727 is equal to 3 over 11. Take note, this is a non-terminating decimal. So, we know that we can rewrite this decimal into this form. 0.27 plus 0.0027 plus 0.000027 and so on. Or, in this way, in fraction form. So, 0.27 is just the same with 27 over 100. The 0.0027 is just the same with 27 over 10,000. The 0.000027 is just the same with 27 all over 1 million and so on. So, from this, we know that we have an infinite geometric series, right? So, the first term in this series is 27 over 100, while the common ratio R is 1 over 100. So, we will use the infinite geometric series formula. S is equal to the first term all over 1 minus R. So, substituting the values of the first term and the common ratio, we have 27 over 100 all over 1 minus 100, right? So, we have to simplify first the denominator. 1 minus 1 over 100 is just 99 over 100. So, to simplify 27 over 100 all over 99 all divided by 100, so we get the reciprocal of the denominator. So, we have 27 over 100 times 100 times 99. From this, we can cancel 100 na. So, we have 27 over 99. So, you can simplify this fraction into 3 over 11. So, from this, we have shown that the repeating decimal non-terminating 0.272727 is just the same with 3 over 11. Please pause the video and try these exercises. If you're done, type your answers on the comment section. If you think Mathusay math tutorial helps you learn math on your own, give this video a thumbs up, share, and subscribe to my YouTube channel. Remember, ang sikreto para maging mathusay, matuto, at mag-ensayo. Watch the next episode and learn about polynomials and polynomial equations on Module 2. See you next time. Bye!